All right, cool. So as promised, it's now 5 minutes after the hour. We've got about 100 people in here. So let's go ahead and get started. All right, so we're going to talk about GUI agents and what they are, talk about the research landscape, and give you a good overall sense of what this task is. I'm Harpreet Sahota, hacker in residence here at Voxel 51. If you've seen me at previous events, whether in person or online, then you know a little bit about me. My background is primarily math, statistics, and coding, and I've been doing deep learning for, at this point, I think almost 4 years. So what are we going to do in today's session? Well, first I want to give you an overview of what to expect in each one of these sessions. We have 3 of them. They're happening every Friday for today and the next 2 Fridays. Then I'll do a brief introduction to visual agents. I'll talk to you about how I got up to speed on visual agents. Then we're going to do like a really interesting deep dive into kind of the research landscape of visual agents. And then, we'll talk about difference between visual agents and VLMs. I'll also talk about, some cool data sets. And finally, we'll close off with some areas of potential impact that you can make if you're a researcher interested in this area. So this session is going to be a review of influential research, their strengths, their limitations, existing research gaps, and my goal really is to give you a clear understanding of the current capabilities, the limitations and opportunities, that you can make in this field. So we're not going to be very technical or hands-on in today's session. It's just really, I say high level, but really it's like a deep high level. Like we're going in depth into the current state of this field, particularly GUI agents. The next series, however, is where we start to get more hands-on. So in session 2 and session 3 is actually we're gonna get a lot more hands-on. So session 2, my goal is just to show you how to create a data set for training a visual agent, specifically a GUI agent. You're gonna get a deep appreciation for what it takes to create a data set, and kind of how to make that more repeatable. We'll talk about the importance of data quality, and we'll get hands-on starting in this session. So there'll be code in this session. Finally, we're gonna take that even further. Session 3 is probably gonna be the most technical session. We're gonna fine-tune a VLM for the task of being a GUI agent. So this is gonna be talking about fine-tuning strategies, handling various challenges with respect to that. Overall, the goal is to just help you fine-tune a VLM for GUI automation using the current best practices. So real quick, let's do a high-level overview as to what a visual agent is. Visual agent is just a system that's going to perceive an environment, make a decision based on that visual input, and is goal-oriented in their action. If we contrast this to an LLM agent, which is all the rage this year, the key difference is we're not limited to just text input and output. We're able to actually process visual information and understand the visual environment. So the capabilities we need to do this is visual perception, visual interpretation, and then making decisions based on this visual input. So it's almost a more natural human-like interaction. And we're ultimately moving towards a space where we have these systems, these AI systems that can engage with both the digital and physical world. And visual agents, they take wide variety of forms, as you can see here. Everything from robotics to autonomous driving to even agents that can play games. But what we're going to focus on, though, in this session and the next few sessions are a very specific type of agent, and this is a GUI agent. GUI meaning graphical user interface, essentially an agent that is able to operate in pixel space on a computer screen. So let's talk about that a little bit more in depth. What is a GUI agent? So a GUI agent is going to take an input as a screenshot. It's going to be able to process that input, so identify the elements on the UI, buttons, text fields, and other kind of interactable components. And then what we get as an output is a screen coordinate and a action to be taken on that screen coordinate. This is awesome because we can get universal compatibility in the sense that we have agents that could work across all platforms, web, mobile, desktop, because they're essentially using the same visual interface as a human. And kind of the loop here, the operation is see the screen, understand what's on the screen, understand the instruction that has been given, and then execute by clicking or typing at the correct location. And this is a really compelling approach to it because now we're able to do basically the same things in a digital environment, specifically a computer that a human could do. And it's able to use a visual interface like we do, so it can navigate software visually. Of course, a pixel is worth 1,000 tokens. Yes, we could use a LLM to parse through the entire DOM structure, HTML structure, and all that, but that takes a lot of computational resources and power. Operating in pixel space is a lot more efficient. And so kind of the architecture, just to lay it out there, of what a GUI agent is we have the environment, which is just a platform that they can operate on, the observation space, which is going to be all the information they can access about the system states. And this is primarily happening through GUI screenshots and sometimes some textual descriptions. Then there's an action space, which is the set of actions that a GUI agent can take, such as typing with the keyboard, clicking, scrolling, swiping, so on and so forth. So we're perceiving the environment, we're taking a task via a prompt, the model runs inference, we have to maintain some memory, and then execute an action. And so the research challenges here is now with respect to perception. We need to handle a large variety of UI layouts. We need to adapt to different interfaces. We need to have an agent that could plan for multi-step reasoning and multi-step sequences, and then break down a complex task into a much more manageable chunk. There's also memory, so it's tracking state and action history, and then execution, which requires some pixel perfect accuracy and really precise interaction. And we'll talk a little bit more about this in depth, but I'm going to pivot now just that we have our bearing straight. We know what it is that we're talking about specifically and what the focus is. It's just OS agents, GUI agents, essentially a agent that can interact basically on any kind of computer or mobile device like a human does. That's what we're going to talk about. That's the focus of this entire series, right? Now what I'm going to share with you, though, is kind of a approach to getting up to speed. So this, as you'll see, this research is vast, and anytime you're kind of approaching a new area of research, it's daunting. Where do you start? How do you get up to speed? And so what I want to share with you is my approach for getting up to speed anytime I'm presented with like a new thing that I need to learn about. First and foremost is survey papers. So I always reach for survey papers, and survey papers from, not only the most recent survey papers, but all older survey papers as well. These are great because they're going to, compile and categorize research into a really clear overview, and it'll give you an idea of where the field has came from, the major breakthroughs, and the current state-of-the-art approaches. And if you are able to pick up survey papers that come from various time periods, then you're able to pick up on patterns across this research as it's maturing. You're seeing which methods and data sets have stood the test of time, are heavily used. You get a better sense of which approaches succeeded and why. And then also you kind of see what areas kind of are unexplored. Also, this is good to get a sense of the benchmarks and comparisons that are happening in a specific niche. So we're able to see what models perform best in different scenarios. We get a good sense of their limitations and best practices for using and implementing these models. So instead of reading like dozens and dozens of papers, these survey papers are really expert curated summaries, and they give you pointers to really fundamental foundational work. You also get wonderful glossaries, taxonomies, background sections, and they just reflect really the collective expert understanding rather than just kind of these isolated results that you get in each individual paper. Question here is, where do I find a survey paper? Very good question, because I'll show you in the next slide. So some awesome survey papers that I've come across while getting up to speed in visual agents are the following. So, I've been into visual agents now, specifically GUI agents, operating system agents, since about May. Early May is kind of where I picked up interest in this particular area, and kind of have brought myself up to speed over the last few months. Like, so by no means am I an expert, but I feel like I got a good understanding of the field. And as you'll see, like this kind of area of research is very new, and it's been booming very recently. And you'll see these trends in just a few slides here. But here are some wonderful surveys that I recommend checking out. So yeah, this is a lot of surveys, a lot of paper, a lot of reading to do. So that's why I say if there's only one survey paper to read, make it this one. It's called Large Language Model Brained GUI Agents, a survey, 100-page survey paper. Of course, 100 pages here. Also includes the references section. There's a wonderful accompanying GitHub repo here that organizes data really well, and just a really, really good resource to get up to speed. Probably one of the most comprehensive survey papers covering research that I've come across. So really good, wonderful resource. They also have this accompanying website that goes along with the paper, so you can kind of drill down by the different types of research, whether it's a benchmark, dataset, model, framework, so on and so forth. And of course, there's the GitHub repo, as I mentioned here. So definitely worth checking out. It's the one I highly recommend. So questions here. Share the GitHub link to the survey paper. Yeah, I'll give you links. If you stay till the end of the slide presentation, you'll get a QR code, which will actually just give you the entire presentation I'm working on here. Data sets like MiniWoB. Okay, we're jumping ahead of ourselves here. So I see someone here is already up to speed. We'll talk about mine too. We're going to talk about these technical details. Hopefully, I'll cover this as we move forward, but we'll definitely discuss this in the following sessions for sure. So stick around for that. Links to the papers. As I mentioned, I'm going to give you a QR code at the end of this where you get the entire slide deck here. So moving on, just kind of building on the research that this work has done, I took it forward in a couple of steps here, as you'll see. So I created like this pipeline that really helps map the GUI agent research landscape. So you saw in the previous slides that they had really compiled this awesome, wonderful data set, really well-structured data set. And so I started with those papers. And what I did was I kind of scraped archive a little bit, not a little bit, a lot. So I took those 180 something papers and I expanded that to over 9,000 papers using doing some citation mining in the sense that, okay, I looked at every one of those 180 papers. I looked at all the papers that they referenced. And so that gives me these level 2 papers. And then I looked at all those level 2 papers to then look at what papers they referenced, right? So I'm getting like a sense of what papers are referencing each other in this field, because ultimately I wanted to figure out what is the most impactful, influential research and research that is kind of hot and trending in directions that the field is going. And I used Qwen 3.8b to do some, well, first after I did this process, this multi-step kind of extraction for citations, I ended up with like 9,000 something papers. And then I filtered those 9,000 papers in using keyword scoring, but like weighted keyword scoring based on presence of particular keywords, and then filter that down to about 600 relevant papers that are really relevant to this field. Then you used Qwen 3b to do more kind of context analysis, and extracted a lot of key contributions and innovations from each paper. Then I did a temporal analysis, and then kind of built a citation network to understand what the foundational works were and what emerging research was. And so this gives us a complete picture of the field's development. And I'm going to share all this with you right now, just to give you a sense of where the field has come, where it's going, and kind of trends in the field of GUI agents. So links to papers, of course, as I mentioned, I'll be sharing all the stuff. You stay until the end, and we'll have the QR code for this exact slide show that you can have. All right, so let's talk about the overview of the visual agents research. So here, this is showing kind of the really explosive growth in GUI research from about 2016 to currently 2024 and onward. And I see like a really classical kind of exponential curve here, where early days research started with just 1 to 2 papers, and then there's a huge acceleration that we see from really 2022 onward. We're in the middle of 2024, so of course the peak was 2025, and we had 285 papers published kind of in this field. And so the trend analysis here, if we continue on with this trend, we might see about 477 papers published by the end of 2025 and 720 papers for 2026. So if this trend continues, then we'll see this. So it's really shown the accelerating kind of pace of progress and growth in the field. Is it going to get to a point where this exponential growth might not be sustainable? I don't know. That's yet to be uncovered, but it's a hot area of research, and there's a lot of action happening. And if we drill down into this just a little bit more granularly here, what I did was an analysis where I bucketed everything from 2016 to 2021 as like the early area, kept 2022 as its own thing because there's a substantial amount of papers there, and then looked at kind of quarter by quarter growth from 2023 onward. And so in the early days of this GUI agent kind of research, we saw a lot of research into kind of this static interface analysis to help figure out which parts of a GUI are actually dynamic and that we can interact with. We saw a lot of early data sets that came out during this period, for example, Rico, and there is early models like UIBERT that were primarily based on language that helped kind of create the foundation of this systems that can operate with GUIs. We started to see a little bit of reinforcement learning kind of bubble up in this area, but not a whole lot. 2022 is where we saw a kind of swell, right? This is the first big spike in research. And here we started seeing large language models kind of integrated with this concept of embodied agents and zero-shot planning. And we saw benchmarks like WebShop that were tested in really complex scenarios. And of course, this is around the time when internet scale pre-training had emerged and showed that doing this internet scale pre-training really improves the capabilities of base models. Moving on to like 2023, like the first half of 2023, so quarters 1 and 2, we see frameworks like Reflection, which is primarily for language models, but we see that we're able to have these language model backbones that could do self-reflection. And we see a lot of swelling interest in this time period for more multimodal agents that are kind of working with not just the DOM structure, not just identifying pixels, but together instructions with pixel space. Late 2023 actually is when things started to take off a lot. And as we'll see here, that there's a huge impact that GPT-4 vision had on the field. So this helped kickstart research that showed that actually we could do zero-shot navigation of GUIs and websites using these large multimodal models or vision language models, however you want to call them. And towards the beginning of 2024, so late 2023, moving into 2024, we're seeing more of a shift towards real-world application. We get more comprehensive benchmarks, and people are starting to think about, okay, how do we come up with these these architectures that are optimized to run on more smaller devices? Second half of 2022, we see more kind of this move towards just operating explicitly in pixel space to take actions rather than parsing DOM structures, HTML trees, or things like that. So kind of moving towards the combination of vision only with language instruction, language prompts. And so there's a lot of research that's happening, and we're going to talk about this in just a moment. So I see there's a question coming in here. I'll talk about that in a second. So yeah, just kind of like the trend of research by quarter, you can see it's just been picking up. And when we look at the different platforms, there's kind of a multi-line chart here. It shows that, mobile has dominated in terms of the type of research that's been done, followed by web. And then kind of the more granular, operating specific stuff has been growing, particularly with just desktop navigation in general. But really a lot of research in mobile and web. And here we talk about the types of research that have been submitted over the last several years. So we're looking at papers that either introduce a new model, a new data set, a new benchmark. We see, of course, that these technical type of contributions, new model architectures, they're dominating. They're peaking at, looks like 160 something in 2024. But of course, we can't have massive growth in model performance without massive growth in data sets. So we see data sets are not too far behind. So you can see here that we're reaching a point where researchers are, producing a lot of interesting work that cover, various aspects of what it takes to, make research viable, in the sense that we need architectures, we need data sets to train those architectures on, and we need benchmarks to test those models against. This graph here is actually, a single paper can introduce multiple things, right? A single paper can introduce a model, benchmark, and a data set, or just a model, or just a data set, right? So I kind of made this stacked area chart that shows like the number of innovations in a sense. So if we count a new model as an innovation or a new data set as innovation, that's what we're measuring here. The gray part here, where there's like 0 innovations, I count those as survey papers. So of course, as the field matures, as things start to, research starts to be published and things start to pick up steam, we'll see more and more research papers. But we're kind of showing a synchronization here in the sense that there are papers being released that are really comprehensive, that introduce kind of multiple contributions together. So talking about the most widely cited papers that I did, that I came across in this kind of aggregation and analysis side that I discussed, it boils down to this. These are like the most widely cited papers out there. And you'll notice that GPT-4 is extremely widely cited, right? So what is it about GPT-4? What impact did this have on this field? So this technical report for GPT-4 really lit a fire in this area of research, because this technical report showed that we can have these models with multimodal capabilities, and this gives us a blueprint now for how to build more open source vision language models that could navigate GUIs. So we see GPT-4 kickstart a lot of interesting things, like, for example, Lava and open source research into how these vision language models can be built. So really valuable resource that kickstarted a lot of downstream research. We also see models like GPT-4, mini GPT that built on this foundation. This particularly had like a 2-stage training approach, that was introduced in the GPT-4 paper, that combined supervised learning with reinforcement techniques, and this became industry standard. And we saw a lot of researchers create specialized data sets like GUI Explore, for example, for training and evaluation. So GPT-4 and just showed what was possible with vision language models or large multimodal models, whatever you want to call them. And this sparked an open source movement that really accelerated the development of generalist agents. So questions coming in here. Question here, goal of 3 lectures. So I talked about that at the beginning of the session. So we're going to learn about the research in this first session, and the next 2 sessions are hands-on. So I discussed that at the very top of the hour. Now let's talk about foundational work, right? So we talked about work that was widely cited. And so what I did was I kind of filtered out some of those papers that were widely cited, but not specific to GUI agents. And so this is what I came up with from that analysis. So we see a lot of work here that happens in the early days, 2016 to 2020. We see that in this area this era of research, there's a lot of data-centric approaches. And these approaches demonstrated that really high-quality, domain-specific data sets are key for GUI understanding. There's a lot of data sets that were kind of domain-aware, and there's a recognition during this time period that the traditional computer vision techniques that we have need to somehow be adapted for dealing with the specific challenges that GUI agents have. And we're going to go deep on those challenges in a few slides here. A lot of foundation work happened here. I mean, modern LLMs and VLMs have transformed capabilities, but these foundational works are still widely cited. They're still critical. They're still important. And they're central to today's research for GUI agents. Then looking even a little bit deeper beyond that, I looked at the commonly cited data sets, of course, just focusing ones that are specific to GUI agent research. And here we see a lot of, newer data sets, but still there's the classic data sets here. For example, Rico. Rico is one of the OG data sets that really kind of pioneered this capture of UI and mobile UI grounding. And it gave us the first very large-scale data set for GUI understanding. Starting in 2023, we saw more kind of multimodal integration. Of course, GPT-4, MiniWoB, Android in the wild. These data sets that were released that then, of course, enabled models to have zero-shot navigation and more real-world interaction by combining vision, text, and action data. We see more benchmarking develop in 2024. We have OS world, Android world, and a lot of similar platform-specific type of benchmarks. But then we also see evaluation that spans not only platform-specific, but desktop, web, and mobile. And so these data sets that we have here, they really drive the innovation in the field because they capture real-world complexity. They have multiple modalities. It helps push us towards more kind of standardization of evaluation metrics, and these data sets are continually increasing in not only scale but diversity, right? So having this scale, having this diversity is what makes SOTA GUI agents possible, and establishing benchmarks that help really define progress in the field. And then speaking of benchmarks, we're talking about there's platform specific. Of course, we saw that in the early 2020s. That had initial standards for kind of mobile UI evaluation. There's benchmarks, of course, like web-centric kind of benchmarks, Web Arena being one, that create a really authentic, interactive websites that have data sets that are really complex interactions and have become gold standard for web agent assessment. We start seeing more kind of multimodal data sets, OS world, Android world, and these other comprehensive benchmarks, which are more cross-platform and really rich, diverse environments. And of course, we see with this that there is, these benchmarks do reveal that there's a huge gap between what these models can achieve as opposed to, human performance. But of course, the importance of benchmarks, as always, is they establish standardized metrics. They then help us reveal critical limitations. They give us a meaningful way to compare different model techniques, and they define what success means for a GUI agent. So it gives us an infrastructure, if you will, that transforms research from kind of experiments and prototypes to something more practical and deployable. All right, so speaking of the types of evaluation metrics that are used, so I want to talk about evaluation metrics from historic research, if you will, and then more recent research. So when evaluating a GUI agent, at the top here we have success rate. And this is typically the primary metric and just measures the percentage of tasks that are successfully completed from start to finish. So it's assessing if this GUI agent is achieving the overall objective, whether that is posting a comment or completing some form. And so we have benchmarks like Online, MiniWoB, and Bear Cubs that have come out in recent years that actually show that there's a huge gap between the reported success rates on older benchmarks and the actual performance of these models on more realistic live kind of GUI tasks. We also have step level action accuracy, and this is diagnosing whether a agent is predicting the right action type and arguments at each step in the process. Of course, for grounding, there's spatial metrics like IOU or click point accuracy, and that's checking if the right UI element was selected. And with this kind of set of metrics, we're able to identify how well this GUI agent is able to really identify and interact with a specific element in the environment or screenshot. So we also have here action grounding. This just verifies if the agent is correctly linking the natural language instruction to what it needs to do on the screen at the right location. VQA, of course, you could do visual question answering over GUI screenshots as well. Here we do, F1 and other ranking metrics here. And a lot of stuff here has to do with like OCR, right? So the agent needs to read the text on the screen so they can answer questions, of course. And the thing that we're trying to measure with these is just the ability of a GUI agent to just navigate a complex layout, the tiny icons, and like the dense text. Before I move on here, let's see if there's a question coming in. Okay, yeah, this is going to be a session. This is going to be posted online later. So evaluation metrics and kind of benchmarks for more recent research. MiniWoB is new. It's recent, but there's these new benchmarks that go kind of beyond that. So Screen Suite, this was a comprehensive benchmark released in 2025, and it evaluates GUI agents across perception, grounding, multi-step tasks on mobile, web, and desktop, uses success rate, action accuracy, and doing it all actually from a vision perspective. On the mobile side, we've got some other benchmarks as well. Mobile Agent Bench, Spa Bench that focus on Android. Crab takes cross-device approach and kind of a graph-based multipath evaluation, very complex. Video GUI, this is kind of for more complex real-world scale. So going from instructional videos and then evaluating at 3 levels. That's planning, narration, atomic action. There's benchmarks that emerge for using a specific tool, right? So Comfy Bench is a very specific tool. There's a benchmark that was released for how well a model can do in Comfy Bench. And kind of hint, what we are going to do in this series is build a model that uses 51, right? The next 2 series that we work through, we're going to kind of do something similar to what was done in Comfy Bench, but focus specifically on creating an agent that can work with the 51 app. It's going to be a lot of fun. VS Bench, this is kind of strategic, multi-agent environment. But yeah, a lot of newer benchmarks that are measuring a lot more than just kind of standard grounding and things that we've seen previously. So we have multiple platforms, modalities, skill levels, and then introducing these new kind of dimensions like efficiency. So how long did it take to generate the answer? How many steps did it take compared to human? And various other kind of metrics in that domain. So coming up here, questions, I'm just going to answer some questions here. All right. Library that makes it easy to fine-tune GUI agents. We're specifically just going to use Hugging Faces libraries for that. That makes it easy enough, so we're going to use that. Question here, will this help me with accurate OCR data extractions? Not sure how to answer that question. MRIs, no, we're focusing specifically on GUI agents that operate in a website, sorry, a web, not a web environment, a desktop computer type of environment. And I'll answer the next question later. All right, so we talked about data sets and benchmarks. Now let's talk about models that have been released. So models have been evolving. We see kind of the early years, 2020 to 2023, having models that adapt a LLM for GUI tasks. Then we start moving into this era of specialized vision language models in 2023. COG agents being a really important model that introduces kind of dual resolution processing and specifically for GUI understanding. We see more multimodal kind of integration in 2024, 2025 with C-Click, Ferret UI, OS Copilot. But we see a lot of changes over time with the type of architectures that we use. So we're going from, multi-resolution visual processing, vision language action integration, GUI specific optimizations, and more kind of advanced training methodologies. So I'm going to move on quickly through the rest of this. Don't worry, you'll get a link to all this stuff. This is the, using the analysis that I've compiled here, kind of what I see as the new classics of the field. These are things that show really, just really high promise with respect to how often they've been cited and the contributions they've made. So really important papers that are kind of the new classics and research that's been hot lately. I see, 5 kind of research directions. The paper, the paper here called An Illusion of Progress, showed us that it's okay to be critical of progress. So it gives us a more realistic online benchmarks that really shows the gaps in kind of, claimed versus actual capabilities. Recently, Kimi VL has been hot. Magma has been hot as well. And these have these mixture of experts kind of designs with native resolution and, this spatial temporal action planning. We see more unified benchmarking, like Browser Gym, that gives us a large-scale multi-benchmark evaluation across a variety of platforms. We're starting to see more research that's moving towards efficient and on-device performance. So TinyClick, LeMac, AutoDroid V2. These are models that are very small and lightweight. And would we work through our fine-tuning? This is kind of the space we're going to operate in. We're not going to work with big 7, 10, 14 billion parameter models. We're going to opt to work with models that are 1 billion or sub 1 billion, and then try to fine-tune those for working with 51 in the interest of efficiency and also just, kind of pushing towards that trend of getting things to run more locally. And I know I covered a lot. All of this stuff actually is in this repo. I'm just going to go ahead and drop a link to this repo right now in the chat. This repo has all the research that I've done, compiled, super in depth. Go check it out. It's what I've been working on really. Probably far more than I should have, but it's really in depth. You'll see here, categorize all the papers and data sets and go through my entire analysis process. All the code here is open source. To answer the question why I used an open source model, Quen, why not? Like, why not? It's, I'm working through a lot of tokens, and Quen is quick, and I have a big GPU, so why not use that and save myself, whatever processing it'll take from a closed source provider. So that's why I use Quen. But all the code is there in that repo, showing you exactly what it is that I've done. All right, so I'm going to come here to the questions before moving on here. A lot of questions coming in. Amit, your question, it'll be answered through the rest of this series. Victor, I think we'll be answering some of your points throughout the rest of this. Hugging Face doesn't provide a way to collect trajectories. No, it doesn't, but I will show you a tool that I built that we're going to be using, and I'll show you how I used it to collect trajectories. So, next week is a hands-on session where we're going to be very hands-on. I'll show you how I built a data set and enable you to do the same. So that's what we're going to touch on next week. Copoly and VLM frameworks, yeah, I think they do fit in this ecosystem, of course. And we'll talk about it right now, actually, how they fit into this ecosystem. So great question, and it's leading into this next point of discussion. So gave you an overview of the research landscape. You get a sense of the types of innovations that are happening. We got a sense of how fast the field is growing and the velocity at which research has been out and what's hot and all that stuff. But let's go back now and say, okay, visual agent versus vision language model, like what is the difference? So when we talk about a general vision language model, we think about what it's designed to do. It's designed to understand visual content, maybe describe what it sees, maybe caption an image, maybe do some question and answering, and maybe even do some kind of visual grounding where it's able to draw a bounding box or produce a segmentation mask for a particular object, right? But the thing about these VLM kind of agents is, first, they're not necessarily able to take action on information in the sense that they can't tell you that this is where I need to click or this is what I need to do. There's no real ability for this model to have kind of state maintenance across interactions. Ultimately, these models aren't goal-oriented. They're kind of passive observers of the world. But a visual agent, of course, they are built on, recently at least, more and more recently, the trend has been to take a vision language model and fine-tune it to behave as an agent. And so these models are now trained for interacting with this digital environment and really affecting their environment. So they're not just observers, right? So they have this kind of perception and action type of cycle where they perceive the environment, they take an instruction, they make a decision, they take an action, they look at the results of that, and they repeat. So they're really able to integrate and act, right? While a general VLM is able to understand and describe. All right, so what do we need, though, to go from a VLM to a GUI agent? What capabilities do we need in this model, right? If we're going to fine-tune a model to be GUI agent, these are the capabilities that we need, right? To have this agency that we've just discussed. We need UI grounding, right? This is key, a foundational capability, really, because the agent needs to map an instruction to a precise visual element on the screen. Of course, OCR is important, right? GUIs, UIs, they're full of text, right? So we need models that are able to extract text from visual elements that are in a GUI. But as you'll see, there's something different and unique about GUIs and the text on GUIs that make it really challenging for a standard VLM to do OCR on this type of environment. Screen understanding, of course, is important because we need to understand the overall layout and content of a screen. And of course, predicting action, right? Determining what the step to take is, right? I'm given a screenshot, I'm given an instruction. Okay, great. What is the action that needs to be taken, right? But GUIs in particular, they challenge vision language models. If we take a look at this vision language models, you will immediately pick on some characteristics of this type of data that would make it difficult for a standard VLM to do well, right? There's a lot of structure. We see that there is a hierarchy in the way it's laid out, right? Elements are existing in some type of hierarchy, right? The grouping of elements matters, right? The spatial dependencies between elements affects the meaning of that element, right? The function of a button depends on where it is relative to the other elements on the screen, right? You see here, for example, that text becomes very unreadable even when we do downscaling, right? And this is important for GUI functionality. So like icons, you see those icons, you see the diagrams, you see the text, they lose their meaning when we have to downscale the image, right, it becomes essentially incomprehensible because you can have a pixel that, an icon that's 10 by 10 pixels, but if that 10 by 10 pixel resides on a 1920 by 1080 screenshot, you downsample that and that thing is virtually disappearing, right? So we need models that are able to detect and process these tiny UI elements accurately. So we need to be able to maintain fine details when handling these really large resolution images. And because of this, we're going to talk about some of the reasons why a vanilla VLM is just going to fail as a GUI agent. So, of course, more and more recent research, like we think about, for example, Qwen 2.5 VL and even Kimi VL, like there's been a trend now where these base VLMs have these baked in agentic capabilities because of the data that they're trained on, but they still struggle. And so here's some specific reasons why they struggle. One is that they struggle with GUI grounding, right? There's two distinct failure patterns that, the research that we kind of discussed has identified. One is that there's kind of a lack of really this spatial inductive bias, right? A standard VLM needs to generate coordinates as a text token. And this happens through a language model head without any really explicit spatial supervision. So then we get this really inefficient indirect mapping from a visual feature to a spatial location. There's also this granularity mismatch, right? Vision transformers operate on patch level features, typically 16 by 16 or 14 by 14. But a GUI interaction means we need precise pixel level coordinate generation. So there's a mismatch here. Right? There's a gap between the coarse visual representations and then the dense coordinate space that we need for accurate clicking. And of course, this all comes down to training data distribution. You think about what a standard VLM is trained on. Primarily internet scale data. Internet scale data is typically not full of screenshots. It's typically full of natural images with captions, right? Not GUI screenshots that have precise coordinate annotations. And so the visual patterns, spatial relationships, and different interaction kind of paradigms in a GUI is fundamentally different from a natural image. Right? One glaring challenge is that GUIs are very, very high resolution. Right? So you think about the size of the screen. Look at the screen you are looking at right now. It is probably massive compared to what a standard VLM trained on 224 by 224 or 448 by 448 is trained on. Like these screens are massive, right? But we need this massive high resolution input because we need to capture these small UI elements like icons, text, and buttons. And of course, like I mentioned, these standard VLMs are trained on these really smaller images, right? So there's this gap with that. Of course, vision transformers also, they have quadratic complexity with respect to image size. So there's a challenge there is that, processing a really high resolution GUI screenshot means that it becomes really prohibitive with respect to computational cost to then train this model, right? So you think about a 224 by 224, right? If we scale that up to a 1120 by 1120, that's a 25 squared increase in pixel count. And so, as we mentioned, this self-attention scales quadratically. So it's computationally can become very intractable and difficult. And there's also different scales on a GUI, right? Think about looking at a GUI, right? You're looking at my screen right now. The text is really big on the screen. The icons up top where it says Chrome, File, Edit, so on and so forth, that's really small. The icons to the far right are a lot smaller, right? So there's different scales that we have simultaneously on one environment. Small icons, text elements, windows and containers, and on this full desktop environment. So this is an inherent mismatch that we have as well. Jim, if your agent can't hover, it can't discover. Hell yeah, dude. Spot on. Banger. I'm gonna get that tattooed right on my forearm. How can you train a better YOLO project with? Mir, that's a good question. We at our visual agents meetup last week, we had somebody talk about that. I'm sure Jimmy will drop a link to Rasul's talk. You can check it out there. In general, You could probably use YOLO for GUI grounding, but as a GUI agent, maybe not necessarily. So we talk about these challenges, right? GUI grounding, high resolution. There has been some really good research, foundational, fundamental research that people have built on, COG agent being one of them. So we have this low resolution branch, kind of for understanding the layout of the screen or the scene, and then the high resolution cross module for text and icon recognition. And then there's like some cross attention that happens between the branches. So COG agent, of course, being a fundamental piece of research that has influenced how we go about fine-tuning and training these models. So a question here, does it ever make sense to design your own procedural UI to apply GUI agent to, or would you simply make that in code steps? It does make sense, and that's what what we're going to do over the next 2 series is we're going to use, we're going to build a GUI agent to interact with 51, which is, I think what you're talking about. The thing with code steps is it's probably not efficient in code, and there's a lot of edge cases and things like that. But yeah, good question. Also, OCR is hard for GUIs. So VLMs do significantly outperform traditional OCR, like without a doubt. Like VLMs nowadays are amazing at OCR, but they still struggle with OCR and GUIs, right? First is the sense of context dependency, right? The GUI text heavily depends on what's around it, right? The icons, the layout, the color schemes, and standard OCR might kind of fail to capture that. There's also character isolation, because GUI text often is now non-standard spacing, overlays, background patterns. Some GUIs might even mix languages or scripts in a single interface. And then, text can appear in various states, highlighted, disabled, focused, different kind of visual properties. And then also just like the scale of text on the screen changes dramatically, right? You get to see this in action on the screen you're looking at right now. So look at the text on the screen. It's different scales from the top to the bottom, different scales. As it turns out, teaching your AI where to click is very hard. As Jim mentioned, if your agent can't hover, it can't discover, right? But it's really hard to teach it where to hover and how to discover, right? Because it has to convert what it sees into like an exact pixel coordinate. And typically, a standard VLM doesn't have this in its training data, where it doesn't have a direct connection between understanding, okay, login button and where to click, right? They're often a little bit too rigid, in the sense that maybe they just want to click at one exact point. But we think about how humans work, we can click anywhere on a button, right? And the way these models are trained, they don't really have feedback, right? They don't really get that right or wrong feedback when training, a standard VLM. So, there's been solutions that have emerged. GUI Actor, which is really, really good. One of my favorite models. I like this a lot because instead of guessing an exact coordinate, it's paying attention to the screen area. And we'll see this a little bit later here. But it gives us an idea of where it thinks it should click or where it should interact. Also, there's the issue of just different loss functions. Most VLMs are going to treat a GUI just like a photo, right? If the prediction is off by a few pixels, they're still going to get kind of a reward there. But on a GUI, we're interacting with like a region and it's a very specific kind of regions and coordinates, right? Click the submit button means you can click anywhere on the submit button and get it right. But if you're just 2 pixels off from the click button, you're going to get it wrong and nothing will happen, right? So we need to understand also where elements are relative to each other. So click the submit button below the form, right? If we're given that as an instruction, the agent's going to fail if it can't parse the spatial relationship that's on the screen. We saw some examples, and we'll see some more examples of GUI layouts. They're dense. There's a lot of element overlap, and traditional VLM might just miss the mark here. They're not going to be able to distinguish or reliably bind text instruction to the control. So there's just a lot of density in terms of buttons and icons and things like that on a GUI screen. So a lot of challenges there. So a lot of reasons why GUI, a standard VLM is going to fail as a GUI agent. But of course, the way we overcome this is data, right? It's the most important piece in the puzzle, data. So to train a robust visual agent, we need different types of data, right? This includes GUI screenshots from a wide variety of platforms and applications, and it needs to be present. We see it now a lot more present in pre-training data for models like Kimi and Quinn. But also the fine-tuning data, right? When you take this generalist VLM and fine-tune it to be a GUI agent, you need specific types of data. So let's talk about that. So of course, we need UI grounding elements. So we need to be able to map an instruction to a visual element. We need to be able to link a command to a specific component on the UI, because this is the foundation for accurate interaction. OCR, as we mentioned, important. We need to extract text from the GUI elements. We need to be able to, quote unquote, read the interface so we can interact with, input forms and things like that. Scene understanding, being able to interpret the layout, comprehending the organization of content on that screen, recognizing the interface structure, and of course, predicting the correct action to take. And this includes what action to take when given the initial prompt, and also given prompts and steps before what we've just done, what's the next step going to be? And a bottleneck here is annotation. I can tell you from firsthand experience over the last few weeks, oh my God, it is the most painful and time-consuming thing I've done in my entire life, is sit there and label GUI training data. It is time-consuming, it's painful, it's repetitive, I damn near lost my sanity more than once. It was challenging, but we need this data. We need really a large volume of this data. And you just look at why it's so hard, right? Look at one of these screens. There's probably like 200 interactive elements on a screen, and each of those needs bounding boxes, element types, and a description for, to go along with that element type, right? We can't just draw a box around button and say button. We need to specify submit a button for the login form at the exact coordinates here, right? And then there's also the issue of interaction traces, as this data set has here, right? So it means recording a sequence of actions and state transitions, and trying to make that a labeling task is challenging. I built a tool that we're talking about next week that kind of makes it a bit easier, but it's still challenging. It still is challenging. But to train a agent to work in a GUI or OS environment, like, it needs really structured annotation, and for that, every pixel matters. So one thing that we need, of course, tons of GUI screenshot data, right? That's kind of the foundation, the bedrock for interacting with the GUI is just raw screenshots. We want diverse coverage, right? If you're doing it for a particular app, then we need kind of diverse coverage of that app. We need various kind of states that app could be in, right? Just talking broadly and generally, if you want to create a really general GUI agent, you need to have coverage across various application types, whether that's productivity, e-commerce, social, different visual themes, different layouts, different scales of resolution. Also might be helpful to have source metadata, for example, like what platform is it from, what application are we using, also screen state context if we need that. Super critical. Question coming in here. Our Selenium. So the thing with using tools like Selenium and things like that is we start operating really heavily with DOM structures and HTML structures, right? And tokens are expensive to process, right? We want to move to a place where now we can operate entirely in pixel space because it is a lot more efficient to operate in pixel space, right? A pixel is worth 1,000 tokens. So, early research for this GUI kind of agent stuff, early days, 2016 to 2022-ish, was using language models for this purpose. But recently, since GPT-4, as I mentioned, since late 2023, we're moving towards now operating entirely in pixel space, right? And this is why vision language models are used for it. Okay, so we talked about GUI screenshot data, but we also need element description data, right? So we need textual content, we need visible text with each element, we need to have alternative text descriptions, we need functional descriptions, submit the form, navigate to the home page, things like that. We need different icons, different style attributes, things like that. Grounding pairs, of course, right? We need instructions and the corresponding element with both visual and functional descriptions. So here there's natural language, so click the shopping cart, multiple phrasings for the same target, and then just varying kind of levels of specificity for that command as well. We need the target coordinate, either absolute coordinates or just an element identifier. We need these pairs, right? GUI, instruction, grounding pairs. Demonstrations of tasks. So, a complete ordered series of interactions to accomplish a goal. This is especially important if you want to build one of these agents that actually does this kind of sequential autonomous thing. If you just want to train an agent to really understand how to interact with your screen or interact with an environment, this becomes less important. That kind of data is fundamental, foundational, but if you want to have something that acts in steps in sequence, we need this type of data, sequential. Of course, OCR training data. This is kind of a bad screenshot, but of course, OCR data here would be strictly for a screen. And then specialized kind of GUI task data as well, and also data augmentation strategies. But crucially, element annotation. So just precise coordinates for all the interactive elements, get some type of element hierarchy relationships and information, get the types of labels for that element. Is that a button, a link, an icon, checkbox, so on and so forth. The functional role, navigate, right? Or action, or input, or display, or do this thing, right? So we need all this to be baked into that instruction. So this is all critical and all important. But of course, the limitation here is we need all this data to train a GUI agent, but we can't rely on these pre-trained vision language models to have this in their pre-training mix, because there's not a lot of publicly available data sets that could be a good starting point. Yes, recently there has been a lot more because now people are releasing more and more data sets like this, and more of the recent VLMs are being having this in their pre-training mix. But we can't rely on public data. So sometimes we need to create our own very specific data sets. So real quickly, I just want to go through. I know we're way past time. Thank you for the 100 of you that have stuck around. Really means a lot. I'm going to go through the next slides very quickly here. I just want to call out some data sets and benchmarks that I like. One of them, ground UI. Really like this. You can see here very precise UI grounding and localization. It also comes with something like 18,000 plus single step instruction screenshot pairs. And very, very cool data set. And we're going to get hands-on with the first half of next week's session. We're going to get hands-on with some data before I show you how I built a specific data set and how you can build your own specific data set. So we'll get hands-on with all the stuff next week. ScreenSpot Pro is another data set that's awesome. This is nice because it covers really specific applications for specific industries, and they used expert annotators to annotate this. So people that had like 5+ years experience using that tool annotate this. Show UI is another good one. So just calling that out here. Wave UI is another data set, not associated with a publication or anything like that, but seems to be a mix, amalgamation, I guess, of various other data sets. What I don't like is across all the data set that I've seen, there's been some kind of output format chaos. I don't see that every data set that I've played with in its raw form seems to have its own kind of annotation format. And it's really fragmented and really a pain to parse through all that. I do wish that there's also kind of a more unified action space that we can kind of coalesce to. Let's have a standard set of actions that can be taken on a UI. Let's name them. Let's all use them. I also have seen data sets that are meant to be kind of continuously, pre-training data sets. So, mid-training data sets that focus especially on primarily just on one kind of platform. And look, I mean, I understand the challenges there. Like the data set that I curated that we're going to be using, it's only on one platform in the sense that it's only on Mac. So I tried to artificially create variations. But yeah, I mean, you got to work with what you work with. It's hard and expensive to create and curate this data sets, but there is a leaning, I guess, more towards kind of mobile and Android data sets than any other data set. And then also annotation quality. I've seen all sorts of wonky stuff in data sets. A lot of data sets have poor annotation, missed targets, inaccurate coordinates, incomplete action sequences, inconsistent labeling. It's a headache. I wish that there was a COCO format for GUI data sets. One doesn't exist, so I invented one, and we'll talk about that next week. I call it COCO for GUI. So we're going to be working with that, and hopefully it gets adopted. I don't know. We'll see. We'll see if anybody ever cites me for that. I think that we should get to a place where models, sure, benchmarks, I think it's okay for a benchmark to have the ground truth as a bounding box, but models, I think, should more and more predict either a point or something similar to like an attention map, like GUI actor does, because I think it could get computation is just expensive and complex to like have models draw a box around an entire, element. Whereas if we have just like a point or maybe some attention map, it might make it a little bit maybe computationally easier to train. I'm not sure, but I just feel like it's unnecessarily complex. I think about myself and a human. If we want to move towards more human-like interaction, just click. Right? I don't think about, okay, I got to draw a box around a particular element. I just kind of click somewhere on that element. Real quick, high level, moving fast because I know we're way over time here. Some models that I like. We'll get hands-on with some next week as well. OS Atlas, really good model. Again, I'm going to give you the link to the slides after the presentation, and all the speaker notes have all of my links to where you could find this stuff, and you'll be able to kind of go more in depth from there. OS Atlas, great model, really robust for UI element localization, really invariant to prompts and system prompts. UI TARS, heavily, this is really new. I think it came out mid-June or something like that. It's very, very new. And it's widely used. I'm just not that impressed by it for various reasons. We can talk about that later, or you could read the speaker notes I put here for you in the slide deck to get my full analysis of it. Show UI 2B. This is a lightweight model. I like it. It's quite fast, of course, because it's lightweight. Probably my most favorite model here in recent times is GUI Actor by Microsoft. You can see here we're getting the output of an attention heat map, so where it thinks it should interact with. I really like that kind of pattern for explainability. It's quite helpful. So definitely awesome, worth checking out. MiniWoB is another model that is kind of a general VLM, but performs really well with GUI tasks as well. And potentially, as I work through content for next week's hands-on session, we might fine-tune this model. I'll see how computationally expensive it gets. But putting that out there. All right, there's a bunch of questions I got to get through here, and we'll do that in just a few slides here. But there's just a high level, just touching on my pain points working with models. Biggest pain point, of course, is prompt engineering. I feel like a lot of VLMs that are fine-tuned for being agents, like they're very sensitive to prompts, input prompts. Like I'm talking a white space will change the behavior of a model, like drastically change the output. And it's a struggle, of course. Next two slides, I think, are the most important ones. This is kind of touching on the gaps in the current research, right? So, we've covered a lot over the last 77 slides, and we've seen there's been a boom in GUI research, but there still are huge gaps, right? Touch on the importance of data, how important data is. But the thing is, data is still scarce. So there's not a lot of diverse real-world data sets. And there's not a lot of data sets for like non-Western contexts, right? So everything out there is primarily English, or, there's been a rise in Chinese data sets, but beyond that, there's really nothing. Generalization kind of seems to be poor. Agents tend to break when they encounter a new app or an OS environment. We're still nowhere near human accuracy. There's also this challenge of computational efficiency that really blocks practical deployment because the models are massive. They're too heavy for edge devices like even a laptop or a phone. So we need to kind of move towards maybe more distillation or more just smaller models. There's also the issue with complex multi-step workflows. That's still a challenge. And there's not a lot of standards for evaluating performance and then ensuring that those systems are secure and ethical, right? So there are some gaps in the current research, and of course, this is how you can contribute to those gaps, right? Data being the most important, and hopefully that I show you next week the tool I built, the tool that you can use for yourself to create new data sets. We need more of those multilingual, culturally diverse data sets and more standardized benchmarks. So of course, we talked about generalization. So find ways to close this performance gap. But most importantly, edge deployment. How do we get these models running efficiently and effectively on laptops, on phones, right? So papers like TinyClick and Octopus, they're leading the way here. Reasoning, right? What can you do for adding memory or planning for multi-session tasks, right? Safety is important, it's critical, right? And these are really areas that if you want to contribute and make a contribution, I think it's ripe for the picking. That being said, thank you very much for being here. I know we went over a few more slides here just to show you where you can get more information. Got a lot of data sets on our Hugging Face org. We'll get hands-on with a few of these data sets come next week when start our hands-on session, so check that out. Give me a follow on GitHub. You can see what I'm up to, see all the models that I've integrated recently. And we can also connect as well. So please do connect with me. So questions, I'm going to try to answer as many of these questions as quickly as possible. First question here, where do we sign up for next week? So next week is just if you go to voxel51.com/events, you'll see that the next two sessions are up. You can register right there. I'm going to drop a link in the chat. So drop a link there. All right. So there's a link to the chat there. So definitely check those out. And I'm going to leave this up while I answer the questions. These are the slides for today's session. So you can grab those here. All right. So starting from the top here. All right. So Amit, your questions, hopefully I've answered them. I think I have throughout all this. If not, they're good questions, but they might take me too long to answer right here. Benchmarks combined with assistive technology. I think I've discussed that already. How do we prepare for the next sessions? No need to prepare for the next sessions. Just kind of show up and, I'll walk you through the code. That's basically what it's going to be. I'll walk you through my code. I'll give you the link to the code later and you can hack around with it. And if you have questions, you can, of course, jump into the Discord community and ask the questions there. So no need to prepare or anything. If you'd like to, you can go ahead and check out some of the data sets that I've shared and take a look at that. Jim, looks like he answered questions. Thank you. Session is always recorded. You'll get it in a few days. Okay, so Jim, do VLMs have access to UI elements accessibility data? This data usually has descriptions of the UI element is meant to do. If you are able to make that part of the metadata of a training data, then you can give it access to that. So I don't know of any like integration with tools that do that. That will automatically give you the accessibility information. I'm sure if like at least not open source ones, right? Like it's very hard. Like the reason I had to build a tool is because I couldn't find a tool that I wanted to do what I wanted to do and output how I wanted it to output. So there's just not a lot of tooling. And of course, as you saw, like the research in this field is brand new. But yeah, that would be critical to have somehow get UI elements accessibility data. I think that'd be important. Yeah, so that's it. All the questions. So this is recorded. Of course, you'll get the link to the recording sometime early next week. So keep an eye out for it. Thank you guys for being here. Appreciate y'all taking the time. Great questions. We get hands-on next week. And yeah, we want to talk all about data next week and then do a little bit of fine tuning. It'll be fun. We're not going to go super like nitty gritty, granular, in depth on fine tuning, just a basic high level overview workflow. But I do, if you have things that you're curious about, ping me on Discord or on LinkedIn, and just let me know and I'll see if I can bake that in.